today we will solve a improper integral of this type using complex analysis. Okay?
Okay.
So first see how we can solve this integral. Integration from minus infinity to infinity x square divided by 1 plus x to the power 4 dx, and we will show that this integral is exactly equal to pi by root 2. Okay? What will be our idea? Do you know what is our idea?
No.
So let me tell what is our idea. Our idea will be, what is idea? We will assume that our fz equal to z square divided by 1 plus z to the power 4. Then what we will do? We will break into two parts. Okay, integration of f of z dz na, we will break into two parts over this gamma. Means what? First part will be along real axis.
Okay, what is
What
gamma?
is gamma?
A gamma is a curve. Gamma is a curve. I will tell you what is that curve. I will just, I am giving the idea now. Okay. So along real axis I will just integrate, then I will integrate remaining some gamma 1 or something. So why I want this real axis? If I do along real axis, this fz, this quantity will be nothing but this one, x square plus 1 by x to the power 4. Okay?
Okay.
Now this will be a complex integral and this will be also a complex integral. Then we can calculate this by calculating these two. Okay, so you understood our idea?
Yeah.
So are you ready to go for the solution?
Yes.
Okay, that's the spirit. Okay, so let's start. So let f of z equal to z square divided by 1 plus z to the power 4. Okay, so first what we are trying to use the Cauchy residue theorem. Okay, so Cauchy residue theorem is telling that, suppose means we can do integral, this integral some formula equal 2 pi I into sum of the residue. Okay, full statement you can see in any book. Okay, so I will not specifying that statement, but okay, this is the idea. So if I will assuming this f of z equal to this one, so can you tell me how we can find the poles of this f?
Okay, we have to equate denominator equal to 0.
Okay, denominator equal to 0 if you put, then okay,
First
you
we have to find singularities and then find what are the poles. So using limiting, so if it limit tends to infinity, or do some calculation.
Okay, first you are telling that we will first find the singularity.
So then only we can.
Okay, then if we are finding singularity, you can see that okay, first we will find the singularity. That means this below term should not be 0, right? If it is 0 at that point, then there will be
call this as a singularities.
Okay, there are some classification about the singularity.
Yeah.
Okay, so first we will try to this one. Okay, so suppose we are putting this one z to the power 4 equal to 0. Then what will be the z, right? What is z we want to find? So okay, if I will do like this, so what we will get, z to the power 4 is minus 1, and you can see that this z to the power 4 modulus is nothing but 1 only. So you can see that mod z also 1, right? So we can assume z equal to e to power I theta, suppose. Means just we want to find what is z. So z will be of this form. So z to power 4 equal to e to power I 4 theta equal to minus 1. Again, you know how we can write minus 1. Minus 1, it can be written as e to power I pi.
Yes.
This is nothing but cos pi plus I sin pi. So this will be minus 1. So this imply what? This you can see this 4 theta and I pi. What is the relation? So since the period is 2 pi, so after each 2 pi the value will repeat. So this 4 theta will be what?
2 pi plus pi.
No,
4 theta equal to pi plus
2 pi
2 n pi. Okay,
Where n is
to 0 1 2 3. Okay, Now, so if you will calculate theta, what you will get? Pi by 4 plus
So n pi by 2.
n pi by 2.
So for n equal to 0.
N equal to 0,
1,
1, 2, 3.
Okay.
Okay. Now we can see what will be the z. Z will be e to power I theta, na. So
Yeah.
first, if we will put n equal to 0, e to power
Power
I
pi
pi by
by
4.
Ah,
Then we will get e to power I
3 pi before. No?
Pi by 4
Pi
plus
plus
pi by 2.
2. No,
3
no,
pi.
no.
Huh.
3 pi by 4.
Okay.
No, no.
Okay. Pi by 4 plus pi
Plus
by
pi
2.
pi.
Okay.
Hmm.
Then
Okay.
e to power I pi by 4 plus 2 pi by 2, and next one e to power I pi by 4 plus 3 pi by 2.
Okay.
Okay.
Hmm.
So these all are the roots.
Hmm.
Okay. Okay, you assume that this is A1, this is A2, this is A3, this is A4. Okay.
Okay.
These all are the roots. That means at this point these functions have singularities.
Ah,
Huh?
yeah.
Yes.
It is not analytic at that point.
Hmm.
Huh? So essentially what we can write, 1 plus z to the power 4 equal to z minus a1 into z minus a2 into z minus a3 into z minus a4. We can write, and we can, because see here degree is 1, so we are not multiplying any k.
Hmm.
Z to the power 4 degree is 1.
Okay.
So this is the exactly the factorization.
Hmm.
So what is our f of z then? F of z is z square divided by z minus a1, z minus a2, z minus a3 into z minus a4. Yes. Now you tell. What can you say about the singularities of a1, a2, a3 and a4?
So these are all pole of order 1.
Yes, you are correct. These all are the poles of order 1. Okay. So observe that a1, a2, a3, a4 are poles of f of order
1.
okay.
Hmm.
So you don't forget what is our aim. Our aim to convert this integral, our aim to convert this integral into the real axis and imaginary means this complex integral. So we are trying to do this one.
Hmm.
So observe this. What is the location of this root? To do that one, we will see that what is the location of this root. Location of a1, a2, a3, a4. Okay. So this is a circle. Huh?
Yeah.
Circle of radius 1.
Less than
So this is the center. So pi by 4 means certainly here, right?
Hmm.
So here it will be. So here it will be a1. Similarly, after 90 degree the pi by 4, here it will be a2,
Hmm.
and here it is a3, right? A3, and here it will be a4. Okay. So now, so the location is like that. So now what we are going to do is, so we are defining a curve like this. This is minus r, this is r, this is center 0, and it is here it is 1, here it is minus 1.
Okay, you are
Okay.
taking r is greater than 1.
Yes,
Ah.
I am taking r is greater than 1. Okay.
Hmm.
R is greater than 1. So now you can see that where is our this a1, a2? It will be
Inside,
it will be inside of this
semicircle.
this semicircle region, right?
Yeah.
So a1 will be here
Hmm.
and a2 will be here.
Okay.
Now we know that these all, since these all are the poles,
Hmm.
so if you want to integrate along this curve, you see along this curve, suppose I am denoting this is as gamma 1, this is gamma 2. Along this curve, suppose I am integrating, the integration will be just 2 pi I into residue of f at a1 and plus residue of f at a2.
Okay.
So why
Here
we are
gamma
choosing
1 is a straight line, na?
Here it is gamma 1 is a straight line.
Minus r to r.
Minus r to r. It is on x axis. X axis.
Okay, why we are choosing a semicircle instead of, so we can choose circle also, na? So for why you are choosing semicircle?
Okay. Semicircle is just to reduce the calculation. We can take
Actually, we are
Yes.
supposing semicircle because we
In
need
the
to real line.
we
how
need
to calculate the real line. So
That
the
integral
value-
over real line.
yes, that
That's
integral over real line.
Mhm.
Also we can do like this also. We can choose this region also. Because doesn't matter, because this region also is contain what is this?
But
A3?
still we
No,
have
you
to took r1.
you can't take a full circle because we need to calculate the value in the real line only. So we consider this gamma 1 as a real line. So
Okay.
we need to calculate this. So that's why we choose a semicircle, I think.
Okay, yes, you are correct.
And
Yeah.
we can choose similarly the below one, means semicircle
below, yeah.
below, and this r1. R1 is important because we need to integrate over real line.
Okay.
Yeah.
So we can choose whatever either we can take down one or below one also.
Yeah.
Below one, but we need to took r1. It is compulsory.
Because we want real
Real
axis.
axis,
real axis.
Yeah.
Yes. Now I understood. Okay. So we will take up one only. So I am removing this one. Okay. Up one. So this, what is this gamma 1 of t? Can you tell me the parametric form? Gamma 1 of t. How I can write in parametric form? This will be only x axis, na?
Yes.
So I can write t plus I0. Simply just it is y axis will be 0. And t is varying from where to where?
Minus r
Minus
to
R
r.
to R.
Minus r to r. Okay. Similarly, what is gamma 2 of t?
It is the circle of radius. So
Circle of radius
R
So
power
R e capital R
r e to power I t
theta,
belong-
I
IT
t belongs to
0 to pi.
0 to
pi.
pi.
Okay. Now I am reminding you, we are doing this one. Okay, we are trying to do in real axis. We will calculate these two integral and calculate this one. Okay. So again, we'll see how we'll do. So now you see integral along gamma 1, gamma 2 of f of z dz. Okay. What it is? We can write this one like this: gamma 1 of f of z dz plus gamma 2 of f of z dz. Okay. Now you will apply our definition, usual definition. So what is this gamma 1 of t? So if I will write this, so 0 to, because gamma 1 is varying from minus r to r. So this is minus r to r. F of gamma 1 of t into gamma 1 dash of t dt.
Yeah.
Similarly, this one also gamma 2 f of, sorry, it is going from 0 to pi, na? Okay. I am writing this is 0 to pi f of gamma 2 of t into gamma 2 dash t into
Yeah.
okay. Now you see this one, this is gamma 1 of t is nothing but this just t, simply t, gamma 1. So minus r to r f of t, and the derivative of t,
One.
derivative of t is 1,
It's 1.
so it is dt
dt. Yeah.
plus this integral gamma up to, this is 0 to pi. What is this gamma?
F of
Capital R.
F of
capital R
r e to power
IT.
it into derivative of this one will be
IR.
I R
ir
e power
IT.
it.
DT.
dt. Okay. So what is this? This will be minus r to r. F of t means
So our
f of t is this one. just t square divided by 1 plus
t for 4.
so this will be t square divided by 1 plus t to power 4 dt. And what is this?
This should be IR, you can take outside.
0 to pi. Okay, so what will get this one? So
R square.
Okay,
r e power I t
square divided by 1 plus r
e power I t power
4 into I r e to power I t
dt.
dt. Okay. So further calculation, see as r tending to infinity, is this quantity will be minus infinity to infinity. Okay, so this is minus r to r t square divided by 1 plus t to power 4 dt. This quantity will be,
This we have to find, and the second one. Okay.
we have to find this one, right? This quantity we have to find, and we have to find this quantity.
One by this one.
This
we
one
can
by
take residual term.
residue.
Okay, we will find this one by residue,
Using residue.
by residue theorem. Okay, and this one by direct calculation. Okay,
Yeah.
by direct calculation. Okay, plus this term. Okay, this is of course. So what we are, okay, final, I am making one conclusion here is, what is the conclusion? This one, minus r to r t square divided by 1 plus t to power 4 dt. This integral equal to this one,
Gamma 1 plus gamma 2
f of z dz
minus integral 0 to
pi IR cube. Just we are calculating this one.
Okay.
Just we are calculating this one. Nothing.
Just do some simplification, you can get.
Just simplification.
Yeah,
we are
IR
getting.
cube e power I theta cube, IT cube. So divided by 1 plus R e power IT whole power 4. That's all.
Okay. R cube. So we are getting e to power 3 IT divided by 1 plus R to power 4
e power 4 IT.
4 IT dt.
Yeah.
Okay. Okay. Now we will calculate these two. First we will calculate the residue of this function. Okay. First we will calculate the residue. Residue of f at a1.
And
Okay.
we have to calculate it both, na, a1 and a2.
We have to calculate it both, then we will sum it.
Then that is exactly equal to integral divided by 2 pi.
Yes, you are correct. So this we can, this is the formula for this one, residue at f1. This is, since it is order 1, so this is the formula. Z tends to z1, z minus a1 and f of z. Okay. This, so we can calculate this is very easily. So how we will calculate this limit z tending to a1, so z minus a1 and divided by, since f of z is 1 z square divided by
Z
this
minus A1.
z minus a1
Z minus A2, Z minus A3, Z minus A4. So you cancel it out, Z minus
cancel.
A1.
Okay, so finally you are getting this one, what you are getting,
A1 square
divided by
A1 minus A2, A1 minus A3, and then A1 minus A4.
okay.
So similarly we can get
Okay,
The
first
residue.
similarly we can calculate f at, but this is not the exact, we have to
we
put,
have to put the values.
we have to put the value, what is a1 a2.
Okay.
So actually it is a very simple calculation. Okay, a1 we know what is this, a1 equal to e to power I pi by 4, a2 equal to, we know, e to power I 3 pi by 4. Okay, a3 is e to power I
5
pi by 4 and a4 is e to power I 7 pi by 4.
Yeah, you
Okay.
can do one page calculation.
Yes, we actually
It's
this
simple.
simple, but okay, one needs to do some hard
Yeah.
work to calculate this one. This is very much simple. Okay, I will just calculate for you. E to power I pi by 4 minus e to power, okay, I am writing in this form so that you can understand very easily how I am taking. Okay, I am writing in this form. Huh? Into e to power I pi by 4 minus e to power I pi by 4 into 2 pi by 2. This is into again e to power I pi by 4 minus e to power I pi by 4 plus 3 pi by 2 into e to power I pi by 4 minus e to power I pi by 4 into 4 pi by 2. Okay?
Okay.
4 done. Huh?
Just take the common e power I pi.
E pi by 4 we will take common. So what we will get? E pi by 4 here square up is there. So here I will common take from each one. So I will get.
You can write 3 now. Why you are writing 4?
Oh, sorry. Sorry. Yes. Only
it's up to 3, na?
up to 3. Okay. Here it is A1 minus A4, na? Okay. I am okay. Yes, correct. You are correct.
So you can erase these two. A4
No,
is
A4
correct,
is just there.
correct.
Correct.
Yeah.
So now if I will do this one, this will be e pi power by 4. So I will common take from each one. So I will get q.
Yeah.
So I will get 1 minus e to power I pi by 2 into 1 minus e to power I pi. Because 2 pi by 2. Yes.
Bracket.
Yes.
There.
Yes, this is the bracket. Similarly here also. Okay. E I pi and this will be 1 minus e to power I 3 pi by 2.
Yeah.
Okay. Now you can cancel this. So you will get, I am taking this one up, e to power minus I pi by 4 divided by. So this will you calculate, this will be minus I, this will be minus 1 and this will be minus I. Just simply put cos I pi by 2 plus cos pi by 2 plus I sin by pi by 2. So you will get this 1 minus I into 1 minus 1 and you will get 1 minus of I. Okay. Then so if you are putting e to power I minus pi by 4 divided by you will calculate this one, you will get 1 plus I 1 minus I. So finally you will get here 2 into 2. Okay. Here it is 2 and these 2 will together will give you 2, a plus b into a minus b. Now this quantity will be, since this is pi by 4, so this is nothing but cos minus pi by 4 plus I sin minus pi by 4 divided by 4. Okay. So this is you can simplify, then this will be, we will get 1 by root 2 plus I 1 by root 2 divided by 4
minus
I 1 by root 2.
Okay, this is minus 1. Okay, minus. So this you will get 1 by 4 root 2 into 1 minus I. Okay.
Yeah.
So what we calculated? We calculated the residue of f at A1. Okay. Similarly, we can calculate. Okay, the calculation what we have done. Residue of f at A1 is 1 by 4 root 2 into 1 minus I.
Yeah.
Okay. Similarly, you can see this. Similarly, you can calculate residue of f at A2 equal to minus 1 minus I divided by 4 root 2. Then finally we reached the step what we wanted actually. So we can now calculate this quantity, right? This quantity by residue theorem. 2 pi I into sum of this one. So this quantity will be this integration of gamma 1 plus gamma 2 f of z dz. This will be what?
2 pi
2 pi I into sum of the residue.
Yeah.
So this will be 1 by 4 root 2 into 1 minus I plus minus 1 minus I divided by 4 root 2. Okay. So this comes to be.
So 2 pi should be in a common, no?
It is in common.
Yeah, you can put another bracket.
Okay.
Yeah.
Yes, of course.
Yeah.
Yes.
You have to-
Yes. So this will get pi by root 2.
Okay.
Okay. Okay. This one integral we got. Next, what is our aim? We have to see what about this integration. So, which one? This one, right?
Yeah.
What about this integration?
We have written.
Okay, here we have to. Okay, we have to do this one. See, if it is going to 0, then our job is done because we got already this is pi by root 2.
Yeah.
Okay. If r tending to 0, if this quantity is going to 0,
R tends to infinity.
As r tends to infinity, this term goes to 0. If this term goes to 0,
Then
we arrived.
then we are done.
Yeah.
Okay, because we already calculate this is pi by root 2. So this will be pi by root 2 and this will be 0.
And the first term does not depending on r.
Yes, this does not depend. This is the beauty. This is exactly constant. So
anyway, it should be constant, whatever it are.
Yes. So now we can estimate something by inequality. We will try. Just you will simply inequality. Our aim is we'll see what is this one. Okay. I r q e to power I 3t divided by 1 plus r to the power 4 e to power 4 it dt. Okay.
Yeah.
What is this? Claim is
R tends to infinity.
when r tends to infinity. The claim is this is actually equal to 0. Okay.
We will try.
We will try. So you know that we know that this reverse inequalities. So this mod a minus mod b is less than equal to mod a minus b. Okay. So I can write this here. I am writing r to the power 4 e to power 4 it minus of minus 1. Okay. Taking this one. So I am taking, of course, this is a, this is b. So this will be mod a. Mod a means r to the power 4 e to power 4 it minus mod of minus 1. And this is equal to what? R to the power 4 minus 1. Okay. And you can see that this is positive also because r is greater than 1. So this quantity is positive.
Okay.
So since it is positive, we can reciprocal, then the inequality will change.
Okay.
Right. So this will be what? 1 by r to the power 4 e to power 4 it plus 1. This modulus will be less than equal to 1 by r to the power 4 minus 1. Agree? Now since we want to estimate, so okay, if we will show this is also tending to 0, I am taking mod. If this is tending to 0, then integral will tend to 0.
Yeah.
Right. So I am taking this mod. So if you will take this mod, what will happen? So I am taking this mod I r q e to power I 3t 1 plus r to the power 4 e to power 4 it dt modulus, and we know this this is, if I will take inside, this will be less than equal to 0 to pi I r q e to power I 3t divided by 1 plus r to the power 4 e to power 4 it
modulus
dt.
dt.
Okay.
Is equal to
This is equal to, see, I will be modulus 1. This will also modulus 1. Okay, done. This is 1, this is 1. So what we will get finally?
integral 0 to pi.
So this will be integral 0 to pi
R cube
r cube
1 by r power 4.
Ah.
Okay, 1 by modulus
Mod.
of this mod 1 plus
1 plus r to the power 4 e to power 4 I t dt.
Yeah.
Mod
Close the modulus.
Okay.
No, but below.
Okay, below I'm because r to power 3 anyhow greater than 0 mod doesn't matter.
Okay.
So now we have estimated that this 1 by of this one is greater than less than equal to this r to the power 4 minus 1. So I am applying this one also here. So here so rq is I am taking outside just. So this is 0 to pi 1 by r to the power 4 minus 1 dt. Now I can take this since it is independent of t. I can take outside also. So this is exactly equal to r to power q divided by r to power 4 minus 1. This is 0 to pi 1 dt.
Okay.
And this is
pi.
pi. This is pi. Pi r q divided by r to power 4 minus 1. Now you can see.
Take r tends to infinity.
See, this tending to 0 as
R
r tending to infinity, right?
Yeah.
Now we are done.
So okay, what we proved? So what we proved actually? What we proved that this integral, right?
Minus
This
R.
integral is less equal 0 when r tends to infinity.
So
And that
this
is always positive, means it is exactly 0 when r tends to infinity.
yes, correct. So this is 1 plus r to power 4 e to power 4 I t dt
tends to
0
as r tends to infinity.
okay. Now we'll come to our final this one here. Where is that one?
Here.
Here. Okay, here. So this tending to 0 as r tending to
And
infinity.
this
So
one
you
we
can-
Okay,
calculated.
applied limit, apply okay,
Now
apply
you
limit,
apply limit.
apply r tending to infinity both side.
Hmm.
Since this is independent of r, so doesn't matter.
Okay.
So r tending to infinite, this is going to 0. So finally, what we'll get here? So this integral is minus infinity to infinity t square divided by 1 plus t4 dt. This will be, we already calculated, this is how much? Pi by root 2.
Okay.
This is pi by root 2 plus
Plus
0.
Yeah.
And this is the
Fine.
proof.
Hmm.
Hence we are done. Thank you for your
Yeah.
thank you for your
Contribution.
not contribution.
Patience.
Patience.
Okay.
Thank you.